The reason I put the topics like this, solving synthesis problem and review for the final, is because I thought this is the last discussion, but actually not. So next week you do have a quiz, but I believe most of you guys did quite well in quiz. So if you really have some other subjects to review, you probably don't need to come for the quiz score. But I bet a lot of you will still come, right? So it's the time to see who are the true lovers and who, yeah. So, and then for the benefit of that, we're going to take a photo together. It's my own cost like a tradition. It's the same selfie that's facing the screen for the whole quarter, and it's going to be facing you guys this time. And I'll be in the middle, everyone pointing at me like a nucleophile. So that's kind of okay. So I made this note before the TA meeting, so some of the points actually is going to change. So this was my the number after each part is the estimation of my own. I think which one is going to be more important. So I put the numbers next to it. He didn't mention this too, but he did told us synthesis is probably going to be 12 to 15 points, but spectrum is actually going to be 4 questions. So I think this will actually change. So it's going to be 25. By describing like that, I think that's the case. But it cannot. It's just my own guess. It's not the real one. And by the way, he didn't really make the whole exam yet. That's even this is what in his mind. It can still change his mind, right? Okay. So the reason I put this one here is I do recommend you guys to go for a practice final. It's like you should start your review now. By the way, although your class is going to finish on Tuesday, next Tuesday, and next Thursday, you will only have to. He's only going to talk about spectrum, which is solving an NMR problem. We did a lot in discussion, so I don't think you guys need the content. Well, you still need to attend the lecture, but your real contents finish at next Tuesday. You should start from this weekend, okay? So what I would recommend you guys to do is first to organize your notes from the last 4 chapters, especially the things after the second midterm, which is alcohol and ether, chapter 8 and 9, okay? You can rewrite your notes into the 59 notes paper. I think you guys know what I'm talking about, right? If you don't, go back to watch the video, okay?
What I want to show you guys is later on you're going to meet something called mechanism, which looks like this. I think last week I worked on this board, resonance, reaction, and mechanism. Okay, a mechanism is the blue part. You are drawing arrows, right? I will call it a sentence. A sentence made up of all those arrows, which is the transferring or the moving of electrons. So this is a note of 118b, which you can do the same format if you want for 118a. Once you start to learn reactions and mechanisms, you put half of the page empty, because it's going to annoy you if you have something like the bump handles and you want to show that and you have lines just come across with your structure. So half of the page with empty and half of the page with line. And something good with it is because if you're printing on both sides, you can still see some lines if you want to draw those reactions in a really good shape. You can, because you can still see the line on the back of the page. That's something I think is really good. But I would say 50-50 is a good percentage to use. I use that for 118b and 118c. Okay.
That's the 2 things for everyone that I recommend, for at least for these 4 chapters, do those stuff. And then you do a practice final to see which part that is the weakest part of the whole things. I classify them in this rank. So reactions, I probably emphasize that a lot. You have Alicia Hertz and Anda Larson, which is the detail-oriented one. Go ahead to practice on those. Mechanism parts, the 5 flashcards we made, and there are totally 12 in chapter 8 and 9. Go and find them. The only difference between chapter 6, 7, and chapter 8 and 9 is you have one more step, which is the protonation of hydroxyl group. If we have the time next week, that I probably will choose specifically a mechanism question like that, and we go through that. But before that, you need to, like what we did in the flashcard, that 5 flashcard, go ahead and make the 12 regs on your own, find them. I told you there are 12, okay? Synthesis part, we're going to go through that today, but as you can see, it's way almost the same as the mechanism, even it decreased a little bit. Like it's not way as much as I thought before. It's still a really important part. I'll tell you why in a minute. Spectrum parts, we talk about that. Your discussion menu, week 8, I know you all practice on that. You can erase your answer and redo all those stuff. He also told me, Neil, professor, also told me, all his spectrum in exam come from the SDBX. So this website is the email link I shared with everyone in week 5. I talk about IR, and I told you guys the IR in your discussion menu is not the real one. In the IR, the discussion menu one looks like really fake. We told you there's a peak, but in reality it's not. You need to differentiate if this is a peak or it's a noise. So I told you guys to go ahead to SDBS website to see what's the real one. This is a database for all neutral, for all the real products, not only the neutral ones, some of them with synthesis. And then it collects the purified spectrum, the spectrum of the purified product in that website. So play with the real NMR and IR spectrum. We definitely is going to give you the real one, not the fake one. Told you we have a peak here. It's not going to be the case, okay? Similarly to your NMR, your peak looks really clear, and you can see there are 5 neighbors. In reality, you need to figure out by your own. And you need to think about, is that a 5 peak or is just a noise? We're still going to make the spectrum clear enough for you to figure out, okay? But there is a difference between the fake peak that we make to let you practice and the real spectrum. Others, I put everything out in others, and I list where specific worksheets that you should go through if you think you are weak in those parts. So by talking about this, you don't have to do all of them. You just need to choose the parts that you are not good with and go ahead to practice on the things. The things I listed here, when I was a student, we don't have this one. So I only did all of the Alicia Hertz exercise. I think maybe including the chapter problem on the back. So that should be fair enough for you to get good grades. As long as you don't look at the answer, don't check the answer before you really try it. That's going to hurt you, okay? Any questions on the second one that we talk about how to prepare for the finals? Questions?
For the category that you labeled as others, do you think that would be more like multiple choice /
Yes.
small answers? Okay.
Yes. So those are the things. Now it's 25. This is the only time it's going to be 25 in your organic exam. In the future, it's going to be 5. Okay, so this is the only time those stuff are 25. So, which means if in 118B, those are 5, where are the 20s go? Think about that, okay? This is the trend. I told you guys, don't spend too much time on this, okay? 2 weeks before your final, I told you guys to do that. Okay, then we are going to focus on, I probably stressed enough, I put this one here because I put this one on my first discussion when I was still using the Blackboard, if you still remember that. I write resonance structure, mechanism, and reaction. So resonance was the one we talked about in the first discussion, right? And I told you guys to practice like crazy on that. Those two, I told you guys in the first discussion that if you meant them in the future, pay attention to those. That is going to hurt you very much. Then I didn't put the synthesis at the bottom because I don't want to scare you guys. We are going to talk about synthesis today. I want to get you guys start not from the discussion menu, start from this. So this is actually the compounds that I made the model of. So this is the model that I just used 2 hours ago. So I'm a PhD student. I'm also taking class. I also have midterms and finals, and we have a final project. So see, you see my name here. See, that's my name. So I just finished presenting those. So what I did, so for us, so what real synthesis people do is we find a nature product from the paper. This one was actually just found last year. So our target is to find a nature product just isolated in the recent years. The professor said last year, then we find the paper in last year. And we're going to propose that this is just for what it is. And we need to remember this word, retrosynthesis. We need to actually separate down the whole thing back into something that you can buy with really cheap price. So this is our goal, why synthesis people exist in this world, is we want to synthesize something that only exists in natural products by just use chemical reactions to make them from really small molecules. Okay, then how we do this? So then I'll zoom out. Then you can see those are all from papers and yield, which means for this transition with these reactions, how much you can get from literature. They probably published before, see the years, different years, and we want to see if we can get this one first. Then can we get this one? Then can we get that one? See, it's already a little complex, and we do want to close the ring here. So we talk about that in the presentation we did today. And finally, it's going to take totally 13 steps. And the yield, although each step is going to be over 90%, after 13 steps, it's still very little. If I put all of them together, see, this is the starting point. This is the end point. This is what a real synthesis looks like. Fortunately, you don't have to do this in your 118A. Your synthesis is going to be just maybe 2 or 3 steps. But this is kind of give you an idea why synthesis is so important that I thought it weighed 25 points. Kind of it's a sub-major for organic chemistry. If your major in the future is organic chemistry, you need to think about, do I need to join a synthesis group or not? Because this is a lot of us is doing this. Make sense? Okay, so now back to your discussion menu and directly turn to the page of the answer key of week 9. You will be really happy. Trust me. This is your synthesis. Do you guys feel happy now? Okay, so the reason I told you guys to go to the discussion menu is just to scroll down, see all of your steps are almost within 3, or maybe this one is the most, is the 4, which means don't overthink it. So one of the synthesis problems that you are going to meet in the future is if I cannot do this way, and you just get stuck there. So I promise you, your final is going to look something similar to this. It's not going to be 13 steps. It's not going to be something you haven't seen before. It's just going to be 3 to 5 steps. Good? Okay, then for how to solving synthesis problem, I copied exactly the same sentence from last week, which means like similarly to solving an NMR. So that's week 9, this is week 8. You don't have to follow my ways for solving synthesis or NMR problem, which means there are a lot of ways that you can do that. It's really similar to, it depends on your own. And then I don't care how you do it as long as your pathway are correct. So when we are grading your finals or any time in the future, even now the synthesis class I'm taking, if our routes make sense, it's the correct answers. So you can have multiple correct routes to the alternate target goal, target molecular. It doesn't have to be the standard answer. Did I make this point clear? So this time you can create your own. And my ways, the 3 steps listed here, you will find out that in a minute. Okay. So I copied on the second problem on your discussion menu, which is this one. This is the question B on your discussion menu. I just copied them down. We are going to try our 3-step synthesis solving method, okay? What's my step 1 say? Count and label carbon in starting material and the target material. So this is our starting material. This is our target material. Then we start to count our carbons, right? 1, 2, 3. And for this one, 1, 2, 3. The reason I put 3 here is because for me, this carbon number 2 is bonded to an oxygen. And this carbon 2 is also bonded to an oxygen. So it's very likely this methyl group in carbon number 3 is exactly the same one as before. For me, it's giving me a strong hint that this carbon didn't change. So 4, 5, 6, and 7. So number 4, 5, 6, 7 are the new carbons that are adding onto the molecule, that telling me there is a carbon adding process somehow during the synthesis result that we don't know, but I will usually do a circle of this. It's kind of telling me those are the new adding parts. Okay, then we start to think. Do you still remember the words that I asked you guys to remember? This one, the retrosynthesis. No, it should be here. The retrosynthesis. Never mind. I think you should know the word. The one that I just pointed out there. Retrosynthesis is also on your discussion menu. It means from the backwards, which means I'm thinking about what could be the last step to make this compound. Retrosynthesis means from backwards. Forward synthesis is just the normal pace that I'm starting from here. So you can start from both ways, which is the step 2. Write possible intermediates that you can choose to do problem in both directions. So when you are doing retrosynthesis, there's a standard arrow that you should use, which is this. So when you are only for retrosynthesis, the R here, only for retrosynthesis, that you will start from your target molecule to intermediate 1, to intermediate 2, to the future. I really should find out my, here, okay. So like what we did in our complicated steps, like this. So possible retrosynthesis. Then that's kind of what I think the possible intermediate doing the steps. And those are actually 4 steps here, 3 steps here. We don't know, but you think this could be a possible intermediate. Did I make this point clear? So for your case, you do all of the retrosynthesis until the starting material, or just the other way around. It's fine. So find out the way that works better for you, because a lot of time, like this question, for me, it's telling me directly. It's a strong hint that it's a carbon adding process. For the final step, that is a reduction of carbonyl with a Grignard reagent. So it's a carbonyl with Grignard reagent. So I'll make this one as R. So RMGX. Step 1. Step 2, acid workup will give me this. And as for what are the carbonyl, so what this carbonyl is, I need to go back forward. If this is the new arginine group, you probably learned it already, the reduction of carbonyl, correct, in alcohol part, in the chapter 8, you learned that already. This is the Grignard reagent, right? What should be the intermediate before? So it's kind of the other way of reaction question. It's not we're asking you what's the product of a reaction. We're asking you what's the reagents of what's the reactant of the reaction. So what this compound should be? You can go ahead to try it. If I list the reagent here already. What's this one? Okay, I'll write directly. So this is the carbon 3. So this is 3, but this one, I mean, it's the carbon number 3 here. This is the carbon number 2. Carbon number 2, and there should be a carbon number 1. So does that make sense? That you do also have something else here. Okay. You can check the answers that this is, there are also 2 hydrogens here. I won't finish it. It's just showing that chemistry happens here on this carbon, that this R group is added on. This R group is added on this carbon number 2. Okay, so you don't need to show this part. It's just for how you think, because I know new carbons were added. And for now, you only learn one process, which is the carbon adding process, which is the Grignard reagent. Okay? For now, you only learn this. Then you probably will get stuck here. So we think the other direction. What can you do with this one? Have you learned this one yet? No? Okay, this is an epoxide. It's a very special ether. We can talk about that later, but currently, you should be able to know if it's basic. So for epoxide, I can just write down here. It's also a review, maybe not review because you haven't learned this one yet. So this is epoxide, E-P-O-X-I-D. It's a special ether. So by the end of next Tuesday, you will learn all of them, okay? So if it's acidic condition, no, acidic on this side. If it's acidic condition, then oxygen will be protonated first. So it will grab the hydrogens in acidic condition. So after that, it will become this hydrogen. And then this bond break, which means if it's acidic condition, this bond break, it's going to look like this. OH. This is a new carbon cation, and that's the new form. And some other nucleophile will come. Which means in this case, finally you are forming something, your nucleophile from the more steric hindrance, which means which side has more carbon, which side your nucleophile will come. And it's epoxide, it can also react in basic condition. Okay, but in basic condition, I'll change the color for I'll change it to green, okay. If it's, I'll zoom out a little bit. Okay, if it's basic, it's going to go through SN2, and if it's SN2, your nucleophile is going to attack this less steric hindrance side and directly form the product. So it's nucleophile O minus. Okay. Usually will follow by a acid workup. So this one will still become, so after workup, this one will be nucleophile and OH. After workup, okay. This is kind of, you haven't learned yet, but for this question you do. So think about if it's basic condition, it will break the bonds that is less steric hindrance. If it's acidic condition, it will break the bonds that's with more carbon. Then come to this question. It's a little fast, but since this question is kind of, you have knowledge that you didn't learn yet. Now we know this is probably the nucleophile, and it's open the less steric hindrance site. It's going to be under basic condition from what we just did here. You will learn this next Tuesday. I just give you a quick, like a forehead review for, yeah, question?
For the difference between acid and basis, is it based off the reagent or is
Yeah, reagent. So you will learn all the reagent next Tuesday. For basic condition, what kind of reagent is considered as base, okay? But I just told you before, and you can take this question, which kind of reagents are basic, okay? For this question, actually, I'll stop here a little bit so you can finish writing. If you think this is kind of, I meant to just talk about synthesis, but we're back to talk about mechanism. See how important mechanism is, right? Okay. So let's back to our synthesis. Yeah, question?
What did you say about which one's more or less steric hindrance?
Because this one is secondary carbon. This one is tertiary carbon. Make sense? Oh, question on this. Actually, I should ask this one maybe next Friday, but it's fine. Just for this mechanism, this two mechanism, question on this too. Good? Okay. Then back to here. We probably know OH is this oxygen, and then OCH3 is going to be the nucleophile. Then this one, I told you the reagents is NaOCH3, and followed by acid water. So after this, I'm running out of the place. So I will squeeze them here. OH. Okay, I will find another paper so you can see clearly what I'm meant to talk about. Good, this one. So after NaOCH3, which is a small strong base, and acidic water, it's become this. And then we know the last step, which is the retrosynthesis. You can think from the other side of this. We know it's probably a Grenier reagent, RMGX, acid water. If this is the case, then it's very likely this one was that one. So from this step to that step, although you cannot see directly, but by thinking from both sides, you can build two things that are really straightforward to each other. Then it's just the oxidation of this alcohol, right? So you cannot, since this problem is not a problem that you can see the answer directly, you need to go a little bit further step. You need to go a little bit like what kind of reactants can react with this one, and how can this product come in? Like you need to think about both ways. And then this is just PCC. Okay. Did I yeah, question?
What's PCC?
You haven't learned that yet? You didn't?
We learned
It's the chromium oxide.
We've learned it.
Oh, okay.
Yeah, okay, it's fine. But this is also a good point to stop. That's why I don't recommend you guys to do the problem on discussion menu right now. Yeah, question?
Can we do the John reaction in this step?
Yeah, you can. Yeah, Jones reagent. I'll talk about that later. Okay. Which means if you are not familiar with what you have learned, which question you raised up is excellent. If you are not familiar with this, doing the problem directly on the back of discussion menu is wasting of good problem because you cannot, you get this one, you cannot get the other one. Makes sense? So, think about the questions that we talked about before. Since it's a problem, do you think it's harder or easier than reaction problem? Vote for harder. Good. So before you really start your synthesis practice, you should go back to do reactions until you can almost 90% get the correct product from any reactions that you have learned already or you are supposed to learn, you are supposed to be good with. Then you can start to do synthesis problem. Otherwise, you will get stuck all over the place. Did I make this point clear? Then if you ask me, what if I cannot get 90% correct on my reactions? Then you go back to mechanism. The reason you cannot write the correct products is you do not understand the mechanism correctly, or you didn't recognize that. So mechanism is the foundation of reactions. Reactions is the foundation of synthesis. Synthesis is the only problem in the exam. Even I allow you guys to open the book, you cannot do them correctly unless you know all the connections in your head. Did I make this point clear? For mechanism and reactions, if I allow you to bring notes, you can get them 100% correct. Synthesis, you cannot. If you don't know it, you don't know it. Okay, then how do we practice on synthesis? Please turn back to the back page of your notes 9. Do you still remember that I talked about 3 things in 118A that I think is important in my first discussion? Of course you don't remember. I will repeat them now. The first important thing is the table of substitution and elimination. You probably know how important that one is, right? I told you guys there are only 3. The rest 2, I gave them together today, which is a reaction map on the back of notes 9, and a page and a half reactions, which is this one. So all the reactions you learn in 118A is a page and a half. See the epoxide one that I just talked about? I just combined all of them together. If you want to know exactly what the base reagent is, there is acidic and basic. This is kind of, but we didn't use exact structure on that. We use R most of the time, which means the R can be changed. I gave you all of this. My initial purpose was to let you guys practice on, can you link all of the reaction on this 1 page and a half reaction page together by a reaction map yourself. So which is here. You have learned, this is chapter 6 and 7, alkyl halide. And you just learned chapter 8, which is alcohol. You change alkyl halide, the chloro, bromo, whatever, into OH group. So you have ways to do, it's basically substitution. Either SN1 or SN2 to here. Can you go backwards? You learn in chapter 8, but you just learned it. You didn't really put them together. This is kind of like a map. This is your first city. Second one and the third one, which is chapter 9, ether. How to make ether from alcohol? Can I return the ether back to alcohol? And I only listed 2 of them here. Is that only one possible route? That's the things you need to think about. First, yes or not. Can I go back or not? Second, is that only one of the routes? Third, which is not, now you should think about, is which one is better, which one has higher yield, and which one costs less. That's something we need to think about. But in your state, you don't. You just need to know does it work or not. Ideally, high yield, okay? So those are the steps. I thought this is going to be the last discussion, and I'm afraid of that you guys cannot do them by yourself. So I gave you the empty map, which is, if you zoom in to see it here, this is alkyl halide, this is alcohol, this is ether. I choose the primary one, and they're the secondary. So these 2 are the same. Apart from those are primary, those are secondary. Now you can start to think about with me now. So I force you guys to practice with me, but I'm not going to fill the whole map. Because you haven't learned everything yet, I'm just going to keep on the things you learned already. It's kind of forcing you to think with me, okay? So you can do, the things I put a click on you can do now, and you start to either open book to refer to your notes, whatever. Try to do them by your own. I'll give you maybe 10 minutes because it's a lot. Okay. So I told you guys you learn this, and then you learn this. Okay. Work with the neighbors, whatever. Start to do that because once I told you the answer, you lost the chance to memorize it by yourself. This is the best time that you figure out, and you will never forget. Okay. We need a small, strong base. Okay. Not E2, so you should not use bulky base. In this case, it's here. Okay, SN2. So this will definitely work. You will have other routes, but later on, at least now you at least need to propose one route at least. After you guess at least one, you think about something more. Do I have more? Okay. How to guess back? You learn that?
Also correct.
Good. Any other choice? Okay. So if it's the tosyl chloride, which is correct, I will use PX3. Remember to use ether. So if I use pencil, means I think that's the thing you learned already. If I use the other thing, which is the ink, it's something that I want you to pay attention to. It's the solvent. So a lot of the reagents, this is not like the reaction problem that I gave you everything. You just need to write the correct product. Now you need to think about which solvent to use, polar protic or polar aprotic. In this case, either is polar aprotic. That you do need to take care of that part. Otherwise, your reagents might react with your solvents, and it's not going to react with your target, like reactants. Okay? So bear in mind, it's important for you to choose the correct solvents. In this case, I'm going to use ink color for all the solvents that I think you need to pay attention to for this part. Okay. So this one is SN2 as well. So SN2. I'll circle the type of reactions. Or HX, that's something later. We just at least get one for each. Okay. Then if we move on for alcohol to ether, you learned that one as well. But now I will just put one of the conditions. Either William ether synthesis. This is something I don't know if you have learned yet. Learned? No? Okay, William ether synthesis next Tuesday, okay? Or just acidic condition. The backwards is actually also the same. Because this is kind of equilibrium between alcohol and ether. It really depends on the condition. Okay, for this part. Later on, you haven't learned yet. Okay, but you do have learned. Let's go downwards first, because someone asked me what is PCC. What is PCC? Have you get the answer from your notes? I put a square of PCC here. This is an excellent oxidizing reagent, which looks like this. So chromium, which is basically why this is, so I'll focus on this square. Chromium is the thing that's really worked for oxidizing. Other stuff is a chloro on this side, is an O- on that side. Or just the solvents. So solvents in this case is pyridine. So pyridine looks like this. But it's the protonated pyridine, so don't forget the positive charge on that. Or the other case that you see is pyridine, HCl. It's also good because HCl, basically the H is here, Cl is here. This is also passable for the solvent for PCC. Okay, I'll stop here for a little minute so you can finish the structure. Another oxidizing reagent, which someone just mentioned before, is Jones. So this is PCC. Jones, I will also write them here, so I'll use another card. Jones reagent. You can just write Jones in the exam, but you do need to recognize that one is Jones if it's in the reaction question, okay? So they all have chromium, so the same word is chromium. But the reason I put water in Jones reagent is also fine because the only difference between PCC and Jones is water. I'll talk about that in the reaction, okay? So let's back to our map. So you should have learned that part already, but maybe it's just somewhere in the corner of your notes that you didn't find it out yet. So for oxidizing the alcohol to aldehyde, aldehyde is the one with the hydrogen. So think about hydrogen, hide. So this one is aldehyde, okay? When oxidize primary alcohol to aldehyde, you use PCC. And if you want to directly oxidize the primary alcohol to carboxylic acid, this one is carboxylic acid, you use Jones. If you want to oxidize the aldehyde to carboxylic acid, this one is also Jones. Which means if you are using Jones, you are going to put the things you have for primary alcohol directly to carboxylic acid. So it's really a strong reagent. Okay, for 118A, you just need to know this, but I can tell you why. Because PCC doesn't have that hydrogen. It's not in water, but Jones reagents have the water. So that's also a good trick to help you guys remember. Think about the carboxylic acid, it has a OH. If you don't have water around, where do those OH come from? So you can think about it like that. So it helps you memorize. Jones reagent is going to push your oxidation forward to the maximum, which is carboxylic acid. Okay? Then how to turn things back? You also learn reduction. The only two reagents you learned so far, so I'm going to write them here. LiAlH4, so I'll use another color. Okay? So reducing agents. Oh, I forgot to change the ether into blue. Okay, I'll change that. I told you guys I'm going to use the blue for the solvents. You don't need to pay attention to that. The reason I need to highlight the ether here is because LiAlH4, which basically works as H minus. In your case, you just need to know it works as H minus. If you have water around or polar protic stuff around, this H minus can grab the hydrogen in water, and it's going to form hydrogen gas, but not to attack your carbonyl. Okay, so you cannot have polar protic stuff with these two reducing agents. Okay, boron is fine, but I don't recommend to use any of the polar protic reagents, solvents for the reducing reagents like this too. So you probably will see problem with use ethanol here, but I don't recommend you to use that. Okay. This one definitely no. So it's either going to be one of the reducing agents. So it's the either one of them is here, the reducing agent. You haven't learned from carboxylic acid to aldehyde yet, but beforehand, I thought this is going to be the last discussion. So I also want to remind you guys, you learned this in 118A, chapter 6, 7. This is chapter 8. This is chapter 9. In 118b, you learn this directly. It's chapter 12 and 13. This one, 118b, basically it's the center of that. It's chapter 17. This one, 118c, chapter 19, 20. So you can see all the organic stuff you learned. You started in 118a. Oh, I forgot to talk about Grignard reagent. Okay, Grignard reagent, we just talk a little bit. It's RMGX. The same Grignard reagent is also a strong base. So Grignard reagent, ether. Second, acid water. You can never forget this 1 and 2, okay? Or RLI, ether, acid water, okay. Back to our big map. So you learn, although you started to learn in 118a, but you are not going to look closely into that until 118b1 and 118c. I'm not going to tier 118b next quarter. I'm back to Gen Chem. So unfortunately, none of you guys are going to choose my section next quarter, or maybe. But the good news is I give you the map. In the future, you can expand the map by yourself, which means I already give you a head start. You need to even during the time that you are not studying with me, you need to go ahead to finish the map by yourself. Okay? I can told you guys there are 2 maps in 118c. Depends on the difficulty that you want to make that map. But I made 2 in 118c. Okay? Don't forget we are going to take a photo together next week, okay? Wear some clothes that you feel comfortable to take photo with me, okay? That's it.